So this is the figure which is given to you. And what is the figure? PQR. Okay, I'll have to go here. Something of this sort. This is P Q R P and this is S. This is 135 degrees. This is 110 degree. Now in this case what they have, these all things are given to you. In figure 6.39, this is the figure. QP and RQ of triangle PQR. QP are produced to point S, RQ is produced to point T respectively. Angle SPR is equal to 135 degree. Angle PQT is equal to 110 degree. Find angle PRQ. This is the angle that you have to find. See my dear students, when you do this, find angle PRQ. Okay, find angle PRQ. Find angle PRQ. See, there are two ways in which you can do this. You can do one thing, which is the faster method. You can see, you can find this. Anyone either use angles in linear pair and find this, or use angle in linear pair and find this. See, two combinations. One set, what you will have to do, angles in linear pair you will have to use, and then exterior angles theorem you will have to use, and you will get it. You can use anything anywhere. See, you can use angles in linear pair over here and then exterior angle theorem over here, and you will straight get the answer. Okay, or you can use angles in linear pair over here and exterior angle over here, you will still get the answer. Second, what you will have to do method is that you use angles in linear pair here, angles in linear pair here, and then angle some property of a triangle here. Three steps you will have to take. I prefer to use angles in theorem, angles, exterior angle theorem always. So I start my solution. First I will use angles in linear pair, anywhere I can use. If suppose I go to use it over here, angles in linear pair, so you can see this is the straight line SPQ. So I will first write, I should be able to guide what I am doing. Finding angle. Now here when I will use angles in linear pair, I will get angle RPQ. I will be finding angle RPQ by angles in linear pair. Okay, property. See, these things if you definitely write, you will get 100 out of 100. Nobody will dare to cut your marks anywhere. Okay, finding angle RPQ by angles in linear pair property. So here you will get angle SPR plus angle RPQ. I hope you all are getting this. Angle SPR plus angle RPQ. Angle RPQ is equal to 180 degrees. SPR is given to you 135 degree. This is angles in linear pair. Now 135 degree plus this one you don't know, angle RPQ is equal to 180 degree. For this you will write substitution, because that is what you have done. And then angle RPQ is equal to 180 degrees minus 135 degrees. This is solving. You are solving. Angle RPQ 35, 45, 55, 65, 75 plus 5, that is 45 degrees. Fine. So this will be angle RPQ. This you have got. See, now we have got this, remember this. And then you have to use exterior angle theorem over here. Now finding angle. Now using exterior angle theorem, this is nowhere in the picture. You have got this and this. These are going to be used. As I told you, immediate neighbor you have to ignore. And these are remote interior angles. Remote interior angles are 1, 2, 3. 3 interior angles are there. Out of this interior angle, which is the immediate neighbor, will be ignored. So only this and this will play a role. Out of this you already know. So this you are going to find. Finding angle QRP by exterior angles theorem, you can say, or property, you can say, anything. So according to this exterior angle, what is the exterior angle? TQP. Angle TQP is equal to the immediate neighbor you will ignore and start from Q. Angle QPR. Angle QPR. Again start from Q, but this side this time you go on this side. Angle QRP. Angle QRP. This is exterior angles theorem. Fine. And then substitution, angle TQP, do you know? Yes, you know this. This is 110 degree. Angle QPR, you have found it over here. RPQ and QPR are same, 45 degree, plus angle QRP. This is substitution. So angle QRP, 45 degree shifted over there, 110 minus 45 degree, again 45, 55, 65, 75, 85, 95, 105 and 5 will give you 65 degrees. This will be angle QRP. Okay, my dear students. So once I have used angles in linear pair, you can see over here, and once I have used exterior angle theorem. This is the faster way of solving, my dear students. Otherwise, I told you, you can dare to be able to solve by all the methods and same answer you here you use angles. So you okay, if we get a chance, I'll definitely show you how to do by that method also. Question number 2. Figure 6.40. This is there again. Here what they have done, that this is a triangle. X, Y, Z, and this is O, and this is 62 degrees. This as a whole is 54 degrees. Okay, now what are they telling? Angle X, here it is given angle X is equal to 62 degrees. Fine. Angle XYZ, angle XYZ is equal to 54 degrees. If YO and ZO are bisectors, this is a bisector, means it equally divides this angle into two equal parts. So YO bisects, remember this, angle XYZ. Similarly, ZO bisects angle XZY. Are you getting? This ZO is breaking this angle into two equal angles, this angle and this angle. Here also they are breaking this into two different angles. Okay, and then they are telling find angle OZY, OZY and angle YOZ, YOZ, this and this. Now it is going to be really nice thing to do. I love to explain these type of questions. drawn, and each diagram should be actually larger one. I am doing thoda sa. See, this you know it is 62 degree. I am writing it outside, and this you know it is 54 degrees. And remember, they are bisectors. So whenever, first of all, you have to know the property of a bisector. See, my dear students, if this is an angle A, B, C, and supposing B, Q, they say BQ bisects angle ABC. That means what? See, it is same like supposing this is A, B, and they say this point P bisects AB segment. If P bisects AB as a segment, see, my dear students, if P bisects AB as a segment, if P is bisecting AB, then it means what? AP is equal to BP. Try to understand. This bisecting means it is cutting AB into two equal parts. If this AB is 100, then AP is 50 and PB also is 50. If AB is 5, then AP is 2.5, PB is 2.5. These both are equal. That is the meaning when we say it is bisected. Similarly, when I say this BQ is bisecting angle ABC, it means the two angles formed are angle ABQ. Can you see this one cut? And the other one is QBC, angle QBC. These are the two cuts, and they are going to be congruent, just like this. They are going to be equal. When you mean this, one more thing is there, my dear students. See, if AB is 40, what is AP? AP will be, when I compare AP and AB, at that time AP will be half of AB. Only when it is bisected. Remember, these all rules are of the bisection. AP will be equal to half of AB, and so BP also will be half of AB. Are you getting? This AB is 40, then PB will be 20, half of AB. Are you getting, my dear students? If AB is known, I will half AB and I will get PB if AB is known. Similarly, here the complete angle, here the complete segment is AB, here the complete angle is angle ABC. So here also any one angle ABQ you take will be equal to half of angle ABC. Whatever is this angle, if this whole angle is 80 degrees, so this will be 40 degrees, this will be 40 degrees. Are you getting? If this whole angle is 60 degrees, so this will be half of 60, 30 degree, this will be half of 60, 30 degree. So angle ABQ and even angle QBC will be half of angle ABC. Are you getting? If I go in reverse fashion, instead that first I told AB is equal to 0. If A is equal to 15, AP is equal to 15, then AB, it will be double of AP. Are you getting, my dear students? It will be double of AP. Full will be always double of the half, and half will be always half of the full. Okay. Similarly, here if I consider the full angle, angle ABC will be actually equal to double of angle ABQ, or you can also say double of angle QBC, anything you can take. See my dear students, this is the property of bisectors. So many things are getting framed the moment you see bisectors. So here we have got this XYZ being bisected by YO. So these are the many sections that will be formed over there. Now they are asking us to find this. See my dear students, think one at a time. You can think anything. See, if I consider only I know this angle is 62 degrees. I know this angle is 54 degrees. I can easily find this interior angle. Angle XZY, because two angles of a triangle are already known. So first I'll write finding what this angle XZY, angle XZY using what? Angle sum property of a triangle. So what I'll get? In triangle XYZ, I'll start using angle XYZ YZ plus angle YZX plus angle ZXY is equal to 180 degree. Reason? Angle sum property of a triangle. Are you getting? See, usually I do like this: XYZ. The next angle I write Y. I start from here YZX. Next angle I write, I start from here ZXY. In that way, I am sure that I have covered all the angles and once only. They are not repeated. So angle XYZ, do I know angle XYZ? Yes, I know that is 54 degrees. Angle YZX, I am going to find angle YZX plus angle ZXY is 62 degrees. This is substitution. Hope you all are able to understand that. So I'll solve this angle YZX. I'll do one thing, I'll add this 554 plus 6, 6, 7, 8, 9, 10, 11, 116. This is going to be equal to 116, and I'll shift it over there and write 180 degree minus 116 degrees. Okay, 62 plus, this is 6 and this is 160. This I have shifted over there, it becomes 180 minus 116. The angle YZX will be equal to what? 16, 26, 36, 46, 56, 66, 76 plus 4, 64 degrees. Okay, if I subtract this, I'll get 64 degrees. This is YZX. Okay, none of these they asked me to solve, but I have understood now. This I have got. This is what? 64 degrees. Now again I come to this figure. See, this is X, this is Y, this is Z, and this is O. Now I know these all three angles. I know this is 62, this is 54, this is 64, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, right? Now if I want to find this angle, can I easily find? Yes, because this OZY will be half of 64. As I told you, OZ is a bisector. See, as we did it over here. BQ is a bisector. If whole angle ABC is 100, so this will be 50, this will be 50, half. So similarly here, this whole angle is 64, ZO is bisecting, so this will be half of 64, even this will be half of 64, but I will just concentrate on this angle. Okay, so finding angle OZY, Z Y here, only this much. Angle O Z Y by angle bisector property. So here I will get angle OZY is equal to half of full angle. What is the full angle? XZY. Angle XZY by angle bisector property. OZ bisects angle XZY. This is given. Fine. So I will get angle OZY is equal to half of 64 degrees. Angle OZY is equal to 32 degrees. In this way I have got angle OZ. Fine. OZY I have got, and now they are asking me to find YOZ, which is over here. See, for YOZ, if I consider YOZ as a triangle, I have got this now. This is 32 degrees. Fine. I can find YOZ, but to find YOZ, I should know this also. Because if two angles, interior angles of a triangle are known, then only I can find the third interior angle. Here I know only one interior. See, I am talking of triangle OYZ. OYZ. I know only one interior angle. I should know the other interior angles also. So I come on. Suddenly I concentrate, focus on this. Angle OYZ. This again, because YO is again a bisector. So OYZ will be equal to half of angle XYZ. Again angle bisector property. So finding angle OYZ by angle bisector property. So what I get? Angle OYZ is equal to half of angle XYZ. XYZ. That will be equal to half of 54. That will be equal to 2 2s are 4, 27 degrees. Therefore angle OYZ is equal to 27 degrees. So now this I have got. And now I can think of triangle OYZ. Two interior angles are known. I will be easily finding this interior angle. So finding angle YOZ by angle sum property of a triangle. Always write what you are going to do further. So in, again, address also is needed in triangle OYZ because there are two triangles, OYZ, XYZ. So where are you going to use? You are going to use it in triangle OYZ. In triangle OYZ by angle sum property. We get what? Angle OYZ. Next will be, I'll start from angle YZ. YZO. Next will be angle ZOY is equal to 180 degree. Why? Now I'll just go. Angle OYZ is what? Angle OYZ is 27 degrees. YZO is 32 degrees. And this one, though, I don't know. YOZ, ZOY, both are same, is equal to 180 degree. This is substitution. Then I add this. Angle YOZ is equal to 180 degree minus this. I will be anyhow shifting over there. This will be 959 minus 59 degrees. Right? 32 plus 27, 59 degrees, and then I will subtract this angle YOZ is equal to 9. But 10 minus 9 is 1, 7 minus 5 is 2, 121 degrees. In this way, I hope you all are getting this, my dear students. If these type of questions are really very interesting questions, you should be able to do this. Don't worry. They are really, if you once you understand all the properties, then these type of questions are really like a riddle. They are like a puzzle. They are like a game. The only thing is that you should know the rules of the game. The one who knows the rules of the game enjoys the game while he plays the game, because he knows how to play with the rules, how to use the rules. That's why those people who know the rules properly and they understand chess, they really enjoy playing chess. Those who don't understand the rules of chess don't enjoy chess. Same is true with Ludo, same is true with Carom, same is true with Damshedas. Those who understand how you are going to communicate, they make their own set of rules, and once those rules they are able to use, they can do anything. Similarly, my dear students, once you know the rules of angles and property, exterior angle theorems, vertically opposite angles, we will be using everything over here. Everything will be coming over here, because these two questions, they are of the topic. That's why they were limited only to angles and property and exterior angle theorem. But let us go further. Question number 3, again over here. AB is parallel to DE. AB is parallel to DE. Now see, alternate angles, corresponding angles, they also will come. AB is parallel to DE. BAC is equal to 35 degrees. CDE is equal to, find angle DCE. Okay, fine. I'll draw this diagram for you people. Okay, not only for you, I also need it. Without drawing diagram, I really can't solve, and neither can I correct. Some students, they able to solve questions without drawing diagrams. I don't know how do they manage that. That level of maths I am yet to learn. This is 35 degree. This is 53 degree. That's all. What all things are given, you should know that. In given we have got, they have given in the question AB is parallel to DE. This is given to you. Angle BAC is equal to 35 degrees. See whether it is angle BAC or it is angle BAE, it is same. 35 degree. Angle CDE is equal to 53. This is nice. 35, 53, 35, 53. Find angle. What is that? DCE. This one you have to find. Fine. This is the question. See again, if I go, this is, to find this, you can very easily see that this angle is already known. Some property of a triangle CDE, then you will be able to find this. But then you should know two interior angles, only then the third interior angle you can find. Here you know only one interior angle. So to know this, you also need to find this. So suddenly your question has become to find angle CED. Now you notice that this is parallel. So I think you must have seen it now. AB is parallel to DE and AE as transversal. You can see angle BAC will be congruent to angle CED because they are alternate angles. Parallel lines is given, alternate angles will be congruent. So here first I will write finding angle CED by alternate angles property. This is your heading. Fine. Now here you will tell AB is parallel to DE. Remember this, you have to bring it to notice because only then you are able to use alternate angles property. And one thing, AE as transversal. Of course, this is given. Angle BAC is congruent to angle, make a Z, CED. Reason is alternate, of course, interior angles property. Now angle BAC is 35 degree, angle CED is equal to 35 degree. This you have got. You found angle CED, and now you will find angle. Now this you have got 35, two angles and 1/3 you can find. Now finding angle DCE using angle sum property. These statements makes wonder, they act like magic in triangle, but of course CD, you have to always give an address where you are using. Here this was an address, this is also an address. In triangle CDE, by angle sum property of a triangle, we get, what do we get? Angle CDE plus angle DEC plus angle ECD is going to be equal to 180 degree. Now we have to substitute. Angle CDE we know 53 degrees. DEC we have to calculate, we had calculated over here 35 degree. This we don't know. Angle ECD is equal to 180 degree. Reason substitution. Then I'll add this and shift it over there. Angle ECD is equal to 180 degree minus 53, 88 degrees. Okay, so angle ECD 2, 7 minus 8, 92 degrees I suppose. Yes. Okay, so this way we have found angle ECD is nothing but angle DCE. So this we have found it like this, in this fashion.